that the time it takes to complete 99% of the reaction is twice as time it takes to complete 90% of the reaction. It is first order reaction. Pretty easy, just find time for both the cases. In one case 99% of the reaction is complete. Let's assume this is T1 case 1 where 99% of the reaction is complete. So the final R will be what? R0 minus 99% R. What? Correct? That is nothing but R0 minus 0.99 R0. And that is nothing but 0.01 R0. First case. Second case, when 90% of the reaction is complete. So the final concentration R is nothing but R minus 90% of R0. And that is nothing but R0 minus 0.90 R0. And that is nothing but 0.1 R. So I have two cases. In one case, the final concentration is 0.01 R0. In both the case, initial concentration is R0. In second case, the final concentration is 0.1 R0. Correct? So what I am doing, I am assuming initial concentration is R0. There are two cases. One case, the reaction is 99% complete. The final concentration becomes 0.01 R0. Second case, the reaction is 90% complete, and the final concentration becomes 0.1 R0. Let's find T for both cases. Case 1 T, T1 is nothing but 2.303 by K log of R0 by final concentration, that is nothing but R. Let's suppose this is the general formula. This is the general formula. Let me write the formula first. This is the general formula. So let me see for case 1. T is T1, 2.303, K will be same, log of R0 by R. R is nothing but 0.01 R0. R0 cancel. This is nothing but 2 into 2.303 by K, because this becomes log of 100, that is nothing but 2. For case 2, T2 is nothing but 2.303 by K log of R0 by R. R0 by R. R in this case is nothing but 0.1 R0. Cancel. This becomes log of 10, that is 1. So this becomes 1 into 2.303 by K. So let's find relation between T1 and 2. Let's divide T1 and T2. T1 by T2 is nothing but 2 into 2.303 K divided by 1 into 2.303 by K. K cancel, this cancel, this becomes 2 by 1. So T1 by T2 is 2 by 1, or I can say that T1 is equal to 2T2. That means first reaction takes twice times as second reaction. Correct? The first order reaction takes 40 minutes for 30% decomposition. Find the T half. So there is a reactant to product. T is equal to 0. Initial concentration was R0. T is equal to 40 minutes. The concentration is 0.7 R0. Why? 30% is gone. Right? This becomes 0.3 R0. Okay? This is X. This is 0.7X. This is 0.3X. Right? 30% is decomposed, 70% is still there. And for this it took 40 minutes. I can find the value of K. The golden formula, K is 2.303. This is the first order equation, by T log of R0 by R, or K is equal to 2.303 by T is 40 minutes. Please note it's 40 minutes. Log of R0 by R. R is what? 0.7 R0. Cancel this. Right? So you solve this, you get the value of K as this. 8.918 10 to the power minus 3 per minute. Now to find T half. T half is pretty easy, 0.693 by K. So 0.693 by K is 8.918 10 to the power minus 3 per minute. Solve this, you get 78. Right? See, we are asked to find T half. You know, T half is nothing but for this first order equation 0.693 by K. That means we have to find the value of K. Right? To find the value of K, we'll use this golden formula. And in this golden formula, all the values are given. The T was given, R naught was given, and R was given. We put all the values, we can easily find the value of K. We found the value of K easily, and then we found the value of T half. The question is for the decomposition of azopropane to hexane and nitrogen at 543 Kelvin. The data is given. We need to find the rate constant, and this is first order reaction. The decomposition is generally first order reaction. Right? Decomposition of azopropane. So let's write the reaction first. This is my azopropane, and it will decompose into nitrogen and hexane. Hexane. That is nothing but C6H14. And if you see, this is gas, nitrogen is a gas, and this is gas. All are gas. And if you see, this is the total pressure is given. This is the total pressure. Given. So here at T is equal to 0, these things were 0, the pressure was 0. So the total pressure is nothing but the pressure of my azopropane, right? Or I can say azoisopropane. So that will become what? My 35 mm of Hg. At T is equal to T, what will happen? This will become 35 minus X. This will become X. This will become X. Correct? So total pressure will be what? At T is equal to T. P total will be what? In this case, 35 minus X plus X plus X. That is 35 plus X. And that is value is given is 54. Let me assume this is 360. Right? That is 54. So X is nothing but 54 minus 35. That is 19. If X is 19, you can easily find these values actually. 35 minus 19 is what? 35 minus 19. 16. So this becomes my 16 actually. Correct? At T is equal to 360. Again, see, I'm assuming it's first order equation. I'm not even sure. At T is equal to 720, let's do this. Let's use the same formula. This becomes 35 minus Y. I'm comparing from this. This becomes Y and this becomes Y. Same formula, same thing will apply here. So here also P total will become what? 35 minus Y plus Y plus Y. That is 35 plus Y. And that value is 63. So Y is nothing but 63 minus 35. Right? That is 28. If Y is 28, 35 minus Y is what? 35 minus 28. This is 28. 35 minus what? 28 is what? 7. Why I am doing this? Because See, the formula which I have for first order equation is K is 2.303 by T log of initial pressure of azoisopropane by final pressure of isopropane. I don't know the values, right, of the pressure of azoisopropane. I have the final total pressure value. So with that I got these values. Now let me apply the formula of first order equation. Assume it is first order equation. So case 1, this is my case 1, 360, right? Case 2.303 by T log of initial pressure of azoisopropane by final pressure of azoisopropane, that is P. Let's put the value. This is the general formula, right? So for case 1, this is my general formula. For case 1, K will come out to be 2.303, T was 360 seconds. Log of initial pressure was 35, final pressure is 16. Mm of Hg, mm of Hg. Anyway, that will get cancelled. Right? You solve this, the value you get is 2.17 into 10 to the power minus 3 per second. Let's try for the case 2. If you get almost same value, that means my assumption was correct, that it is first order equation. So let's put the value. K is nothing but 2.303 by T. T will be 720 minus 0. I am using these two set now. That is by 720 log of P naught. Initial was 35 mm of Hg. Final is 7. You solve this, we get 2.2 into 10 to the power minus 3%. You see almost same value. Almost same value. So I can say that my assumption that it was a first order equation is correct. I can find the average of K also. Average of K will be nothing but, you do average, you will get almost 2.2 actually. Yeah, 2.19 or something. Almost 2.2. Yes. Into 10 to the power minus 3%. So what we have done in this case, the experimental data was given. We didn't know what is the order. We assumed it is first order equation. And then we found the value of K for two scenarios. Using the first order reaction, we found the K value came out to be same. That means it is the first order equation. If you want, you can assume it to be zero order equation. Try with that. You'll see that the value of K will not come out to be same. Then you can assume it to be first order and put the values. Or you can use the graphical way also, right? You plot the graph A versus T, log A versus T, different combination which I just explained, and see which one you are getting straight line.